So let's talk about vapor pressure first so we can understand what vapor pressure lowering is. Okay, so vapor pressure refers to the partial pressure of a gas in equilibrium with a liquid. Okay, or so if imagine you have, let's say, a beaker that has water in it. What will happen if you just leave that beaker lying on your bench top? And it eventually dries out, right? So your liquid leaves. So the way you interpret that is your molecules are able to leave your liquid and eventually they all go. But what happens, okay, if instead you put a lid on that? So you cover that beaker so it's airtight. Okay, so no molecules can leave, no molecules can come in. What will happen? It's not going to dry out, right? Now, uh, but eventually what happens is if you monitor the pressure of this, okay, let me make a better sketch here. So I have a sealed container where I have a liquid. Eventually the rate at which your molecules leave the liquid will be equal to the rate at which the molecules go back to the liquid. So eventually the gas in here is going to have a constant pressure as long as the temperature remains constant, okay? So at a given temperature, we say that the pressure of the gas that will be in equilibrium with the liquid, we say they're at equilibrium. Equilibrium means the rate of vaporization will be equal to the rate of condensation. The pressure of the gas that you have there is called the vapor pressure of your liquid. Okay? So that vapor pressure is constant at a given temperature. If you raise the temperature, you'll have the molecules will have a greater tendency to escape the liquid, so the vapor pressure will increase. That makes sense, right? You give them more energy, they're better able to go into the gas phase. So that increases with temperature, and when that vapor pressure reaches 1 atmosphere, then we say we are at the normal boiling point of the liquid. Okay, so when water, in other words, when you have water, okay, you increase the temperature of the water. By the time you get to 100 degrees Celsius, your water starts to boil, right? And that's the point where the vapor pressure of the water is going to reach 1 atmosphere. Okay, so that's called your normal boiling point. Okay. So let's see if you understood that concept. All right, so here's a clicker question. Consider two identical enclosed containers. Closed containers are shown here on the right with different amounts of water. So this is liquid water right here, okay? And so that will be in equilibrium with water vapor, right? At equilibrium, at the same temperature, so both containers at the same temperature, in which container will be the partial pressure of water be higher? Is it container A, container B, or will it be the same? Oh, I'm sorry. Start falling. Okay, so let's stop the poll. Let's see how we did. All right. Let's go back to that slide, previous slide. Okay. The vapor pressure is constant at a given temperature for a given liquid. Two liquids are both water. They're at the same temperature. You want to try it again? Let's see how we're doing this time. Better. Okay? So, for as long as you have gas and liquid at equilibrium, okay, same temperature, the vapor pressure will be the same. So how can the vapor pressure be the same here if we have different volumes? That simply means you get more molecules. Let me just go back to this one. The correct answer for this was C, right? That simply means that in container A, you have more molecules of water in the vapor than in container B. Okay? If you remember from your ideal gas law, PV equals nRT, right? P equals nRT over V. Okay? So if you're going to have the same pressure, okay, then that means you're going to have the same concentration. Since a bigger volume simply means you're going to have more moles there of water vapor. All right, let's do this one. Consider the two identical containers again at the same temperature. I just gave you the answer to this one. Okay. At equilibrium, same temperature, which container has more water molecules in the gas phase? A, B, or neither? Stop that. Okay. What did we say the vapor pressure was in both of these cases? The same, right? So PV equals nRT. So if we want to compare N equals PV over RT. Okay, the pressure is the same in both containers. They're at the same temperature. You're dealing with the same liquid. R and T are the same. R is a constant. Temperature of both containers is the same. Which container has more volume? More volume of gas. A bigger gas volume. So you have more gas in A. The volume of the gas in A, that means you have more moles of water vapor in container A. And that's how it's able to have the same partial pressure as container B. You just have more molecules in container A. So the correct answer here would be A. Okay? The vapor pressure of water at room temperature is A, less than 1 atmosphere, B, equal to 1 atmosphere, or C, higher than 1 atmosphere. Right? Let's see how we did. Okay. What did we say happens to vapor pressure as you raise the temperature? It increases, right? And once the vapor pressure reaches 1 atmosphere, then that's when it starts to boil, right? So at what temperature does the vapor pressure of water reach 1 atmosphere? At what temperature does water boil? 100 degrees Celsius. So at room temperature, the vapor pressure of water must be less than 1 atmosphere. It's not boiling at room temperature, right? So the boiling point of water is 100 degrees Celsius. That's when its vapor pressure reaches 1 atmosphere. So at room temperature, its vapor pressure is less than 1 atmosphere. In fact, if you were to plot vapor pressure versus temperature, you get something like this, okay? So when the temperature reaches 100 degrees, in the case of water, when this temperature reaches 100 degrees Celsius, your vapor pressure reaches 1 atmosphere. In fact, at room temperature, at around 25 degrees Celsius, your vapor pressure is about 23.8 torr. What's 23.8 torr? How many atmospheres is that? Do you remember how to calculate that? It's 23.8 divided by 760. That's 0.03 atmospheres. Okay? That's about more or less what the vapor pressure of water is at room temperature. All right. Let's try this one. Ethyl alcohol boils at 78.4 degrees Celsius. Which of these two liquids has a higher vapor pressure at 78.4 degrees Celsius? Water or ethyl alcohol? So if ethyl alcohol boils at 78.4, what's its vapor pressure at 78.4? 1 atmosphere. So if I were to plot vapor pressure versus temperature, for ethyl alcohol, it's going to reach 1 atmosphere. So here's 1 atmosphere. For ethyl alcohol, it's going to reach 1 atmosphere at 78.4 degrees, right? At what point does the vapor pressure of water reach 1 atmosphere? Water boils at 100 degrees Celsius. So the vapor pressure of water reaches 100 degrees Celsius, 1 atmosphere at 100 degrees Celsius. Correct? So which one has a higher vapor pressure? At 74, at 78, you know at 78.4, the vapor pressure of water is less than 1 atmosphere. But if alcohol is already boiling at that point, then the vapor pressure of alcohol is 1 atmosphere at that temperature. Okay, so we say that ethyl alcohol is more volatile. Okay, it's a greater tendency to go into the gas phase. It has a higher vapor pressure, lower boiling point. So the expression more volatile is synonymous with having a higher vapor pressure or having a lower boiling point. Okay? So how did we do on this one? Correct answer? You got it right.